welcome back. We have a nice question here from Sanisha Maharaj. However, we have Yasin on the line. Good to have you with us again. How did your exam go on Friday?
I was quite surprised. I took the paper for quite a joy.
Okay, that's very good. I'm pleased to hear that. That's very good news. So
Yes,
you prepared yourself well and got yourself ready. That's great.
Yes, ma'am.
Now, I believe your question, you were sent the picture through, but we couldn't quite get it. So we're going to use this question, and hopefully you can ask me questions of where you're getting confused
All right, no
around
problem,
it.
ma'am.
Okay. In the diagram below, A, B, and C are 3 points in the same horizontal plane. So Yasin, are you sure what you understand when they say that?
I'm sure I do, madam.
Right. Basically what it means, for those of you who don't, or I'm sure you all do by now, it means on the same floor.
All right.
Okay, now it says D is vertically above. So that means here we have, if you like, this is my surface thing, and here I've got vertically above. So it's vertical to the ground. Okay, they've given you a drawing, so they usually do that. They don't have to, by the way, I hate to tell you, but usually they do give you the drawing. The angle of elevation of E from D is theta. Now, as soon as I see the angle of elevation, let me just make sure I'm on the right color for the white paper. I like to think of it like this. I say, imagine your eye here. This is your normal line of vision.
All right.
And an angle of elevation would be looking upwards from your line of vision. And F is a point on EC so that DF is parallel to BC. Now, we're going to go look at the drawing in a minute. I've just read the words through, and then we're going to look at the drawing with the words. But before I move off that, that is an elevation. Obviously, the same would apply for depression.
Okay.
So again, I'd have my eye, I would have my line of vision, and I would look downwards to get my angle of depression. Okay, fortunately this question doesn't have that in, but I just always think put your eye where they're telling you to work and you're fine. Right, so let's go to the actual thing. Now it says there are 3 points on the floor. What they normally do is they shade the floor. So the moment they've done that, they say that D is vertically above that, so we can see the right angle here. And then they say B and E is vertically above B and E. Am I reading this right? Above B, and E is vertically above C. So again, it's vertically above, so we can have another right angle over there. The angle of elevation of E from D is theta. They've been very kind to you. They've actually given it all to you on the drawing. But with me, excuse me, I shouldn't have sneezed. I do apologize. Over here, we would have gone along and we would have said, here's our normal line of vision. Here's our angle of elevation. But they've done it for us, so it's actually made it very, very easy for us here. Now, what I would do before I even started is I would finish up filling in everything I can gather from what is being given. And first of all, what do we know over here, Yasin?
Well, which one is it, ma'am?
This angle over here at the bottom, let me just lift the screen a bit higher so you can see it.
Okay.
What do you know about the size of that angle?
Is that it's right angle?
Okay, this one up here is the right angle, but if we're concentrating in A, B, C,
All right.
okay, what I like to do if people are having trouble with the 3 dimensions is to
ma'am.
just draw little bits. So we know that that's alpha, we know that this is beta, so what would that angle be? Well, what do we know about 3 angles in a triangle?
Is that they are all equal?
Are they all equal? When would they all be equal?
They'd all be equal if it was isosceles triangle.
If it was equilateral, they would all
Right,
be
ma'am.
equal. And isosceles, 2 of them would be equal. But now we don't know that in this drawing. We do know that this is B, but we don't know about the lengths of those sides. So how would we, if I gave you a simple example, say something like this, and I said this is 60 and over here is 50 degrees, would we have any trouble finding that angle?
No, ma'am.
No. What would you do?
I think I would use my cosine rule. I'll see if I have both angles, and then if I have both, then I can use my sine rule.
Okay, now to know that we would have to have a side. Fortunately, we do have a side here. But I'm just thinking simply, if I want to work out that angle, surely I know that these 3 angles add up to 180.
Right, ma'am.
So this angle B plus the alpha plus the beta must equal 180 degrees, which means the angle B is actually 180 degrees minus the alpha plus the beta.
Okay.
Now, we might not need it, but the chances are we will, because we've got 2 rules we work with predominantly in this section. The one is sine rule, the one is cos rule. Sine rule we use when we know 2 angles and a side. In this case, that would be 2 angles and a side. And we would actually have to find this angle because we'd have to know the angle opposite the given side to use sine rule. We then also have cos rule, and well, finishing up sine rule, we also have two sides and one angle, and once again, the angle would have to be opposite one of the given sides.
Okay.
Cos rule, you'd have to know three sides or two sides and an included angle. So in this case, definitely cos rule is not going to work on that bottom triangle. So definitely we have to find that missing angle, which we've now found over there. I would suggest that you actually show the steps. So I would do this somewhere in the working, and I would say angles in a triangle. Oops, that wasn't very good. Did you do paper 3 by any chance?
No, ma'am, not a chance.
Yes, you see now that's what's not nice. You see that people with paper 3 would have a little bit of an advantage here because they would have worked with their normal geometry. But you know, it's not bad, it's basic geometry. It's just that you must remember that angles in a triangle add up to 180.
All right.
Now, we do know that these are parallel, so that means that this would be a right angle, and this would be a right angle, and that would be a right angle because they would be angles on a straight line.
Yes, ma'am.
So now we go back, and of course this time you're going to know how to find this one for me, aren't you? How would I find that one?
All right, then I think what we're going to have to do is that we're going to, since we know both of them are parallel, then both of them will be equal to each other.
Okay, now where are the parallel lines? The parallel lines are actually here and here. This one's not parallel, but we do have a triangle over here. So what have we just done when we knew two angles and we wanted to find the third one? What do we know about angle E?
Oh, okay. Angle E is opposite, or rather adjacent to angle B.
Okay, so you're wanting to work with adjacent. You're saying E is adjacent to which angle?
To angle B.
Is that adjacent? If we talk about adjacent, what do we mean?
It has to be opposite each other, right?
Now, adjacent would mean next to each other. So like your next door neighbor is adjacent to you.
Oh, okay.
So careful, there's no angle near that. But we do have a triangle again. So remember how I did it? I said that this angle plus that angle plus that angle. So the theta plus the 90 is equal to 180.
60 degrees.
So that means that E is equal to, now if I bring the 90 over, that'll make that 90 minus theta. Okay, so this is 90 minus theta, and again, it's angles in a triangle. So already, I think if you're having trouble, this is probably where you're having it.
Yes,
Am I guessing right?
Yes, ma'am, you are.
Okay, so definitely for you, I want you to make yourself, as you get into the exam, the first thing you do is you do this little drawing in the exam. I'll just show you at the bottom here.
Okay.
Draw a little picture like this as you get in, and write yourself the following note. A plus B plus C equals 180 degrees. And then when you get to this question, you say to yourself, okay, I just need to remember this, because that seems to be where you're sticking, because you're not realizing that you can't get off with a question. So I think if you do that as you get in the exam, and that's a hint to anybody who didn't do paper 3, if it's something you're going to forget, rather do that. And then one other thing I think is worth writing down is if you have something like this, then we know that A1 plus A2 is 180 degrees as well, because angles on a straight line add up to 180 degrees. Those are the two real basic necessities, let's put it this way, of our trig. If we don't know that, we can be in for big trouble. As I'm sure you've realized, they're not fun otherwise.
Yes,
right, so please remember that. That's worth remembering. Let's go back to the question.
Okay.
So what I'm going to do now is I'm going to just tidy it up a bit because I've had a field day scribbling all over it, as you can see. I'm just going to take the shading out. And of course, what's nice about your paper, you know, of course, is they always have two drawings, the one in the paper and then the one in the diagram sheet. So if you mess up the one in on the paper, you certainly can use the diagram sheet one, or vice versa. So you can always tidy it up or work in pencil, that way you're safe. But I quite like color because it helps it stand out for me.
Okay.
So I think the color is a good idea. It sort of helps you to get your picture, and also you can shade your triangle. So there's a triangle. I can use that rule that I was shown and find the missing angle. Now, I might not need what I filled in, but I find that once I've done that, once my pupils have done that, the question just becomes easier because you don't have to think too hard. You've got everything you need in front of you. Right, so let's have a look at what the question says. The question says, prove that DE, now what I would do is I'd go along and I'd highlight DE, just in case I forget what I'm looking for, is equal to B, so I need to have a B involved. An alpha plus a beta, well, there's an alpha plus a beta, so we know we're going to use that angle. and a theta, so we're going to use that angle there. Now, the problem is that these things are coming from completely different triangles. But what is important here is one other geometric fact, and that is that what type of figure is DFCB?
D, F, and CB would be a triangle.
Careful, DFCB.
Oh, DFCB.
Yeah, sorry, I nearly used the E, but it's not. It's DFCB. With all these little right angles, what are they telling me this is?
A triangle. Oh, no. They're telling me it's a rectangle.
It's a rectangle, yes. Okay, and what do we know about rectangles? What quality do they have? Opposite sides are equal. So this orange line is equal in length to this orange line.
Right.
So once I've found this orange line in this triangle, I can transpose it to that triangle. Why not?
Right, ma'am.
And that's the secret of the question. Sometimes it is as easy as finding a shared side, a side common to two things, but this is a little bit more difficult. So, Sanisha, we have to thank you for this, because this is one that we have to realize the properties of a rectangle as well as solve the problem. So, very nice question. Okay, so over here we go, and we're going to start over here. Very important, in order to work in any triangle, we need three facts.
Right.
And one of them has to be a side. So we've only got two triangles that we can work in here. The top one, EDF, where we know three angles but no sides. And then we have BAC, where we know three angles and one side. So that's quite good news.
All right.
So we can definitely work with that. I'm just going to make it nicer looking. Right, so if we look over here, we've got three angles and one side. As long as we have a side opposite an angle, we can use our cos rule. Now, I'm just going to show you this, which is quite interesting. I sometimes show my pupils something like that. I say, if you can do that, it's sine rule, where you've got the angle and the side opposite. So that's going to be a sine rule. So what am I going to do? Okay, it helps a lot like that.
It does, ma'am, it does.
I want to find this BC. So I know that the other one I want to find, and I'm just going to use dots for it, must involve that. So it must be BC with sine alpha. Okay, a nicer version of this, perhaps less untidy, is to use arrows like this. But I quite like this little figure eights thing that sort of helps you to realize where they connect.
Yes, ma'am.
So what I would do is I would start with BC over the sine of the opposite angle. Now, why did I put the BC at the top? Well, that's what I want to find, because I know once I find BC, I actually know DF as well.
All right.
So that's why I put the thing I want at the top. It doesn't matter if you don't. You can put it at the bottom and manipulate it. It just makes your algebra more difficult. And we want to try and avoid that if we possibly can.
Yes, ma'am.
So that's B over the sine of, and of course the angle opposite is 180 minus alpha plus
Theta
beta.
minus B.
Okay. Now that's quite nice, because now I've got BC, and I can take this and multiply it across to give me B sine alpha.
Okay.
And what do we know about this? This is 180 minus. So it's in the second quadrant. What do we know about sine in the second quadrant?
It's positive.
Correct. So this side becomes B sine alpha over sine alpha plus beta.
All right.
Because remember, these sides are equal, so I've just made myself a little bit lazy, but let's be good and put it here as well. And we can see that those are definitely equal to each other.
Yes, ma'am.
Right, so now we can move to the other triangle, and really that's where I want to be, because I want to get this green side here. So that is really where I need to be. So let's just get rid of this, because I don't want to leave the drawing. It's always easier to see what's going on if we have the drawing in front of us.
All right.
And so I'd rather just keep it handy. I don't need this stuff anymore, so I'm just going to take it off. Right, so here we are, and we're about to start working in that triangle. Now remember what I said to you, we need to know at least one side. Do we know one side, Yasim?
Yes, ma'am, we do.
We do. Now, what rule would we use if we have three angles and one side?
We use the sine rule.
Sine rule, correct. Okay. And if we use my little dotty method, you can see there's your link if you like.
Yes, ma'am.
Okay, so we could use sine rule. Some teachers avoid using right angles as sine rule, but really it doesn't matter. And we want to get this, so we're going to work with that pairing over there. And you can use that little eighth thing I showed you if you want to have a more flowery version of that. So what I'm going to do is oh my gosh, that was nearly a mistake. It's just, sometimes you move the screen and you don't realize it's all moves at the same time. Right, so we have DE, which we want to find, over the sine of its opposite angle, which would be sine 90 degrees. And I know some teachers are probably sitting at home flinching, but if they're realistic, they'll know that that's how all the pupils do it. And this is B sine alpha over sine alpha plus beta. And this would be over the sine of 90 minus theta. Now, why the teachers are flinching is because this makes your arithmetic quite difficult, whereas the right angle triangle way would just be a little bit easier. And I'm going to show you the right angle triangle way as well, Yassine,
Okay.
so you can see and you can decide for yourself what you prefer. I just know from experience this seems to be what my students mostly do, even if I try and encourage something else. Right, so now over here we've got 90 minus. What's going to happen to it?
It's we have to see in which quadrant it falls in. So if
That's
it's 90
right.
minus. If it's
So-
90 minus, it would fall in the first quadrant. Everything is positive.
Yes, in the first quad, everything's positive, so it's just going to be cos theta. Now I'm going to put it over 1 because now I've got a fraction over a fraction. So that is equal to, and just so we don't get confused, I'm going to leave this over here. And then I'm going to invert the green one at this stage.
Okay.
So it's times by 1 over cos theta. Which then means I have B, I think I'm going to stick to the blue. The blue seems to show up nicer on the white. B sine alpha, and at the bottom here I've got cos theta sine alpha plus beta. Let's see if that's what we wanted. It is exactly what we wanted.
Yes, yes.
So you see, I didn't get worried about what I was heading for. I just used the common threads of what we have to do. Just to show you so that you can see that there is another way to do it. Let's quickly look at the possibility of doing it the right angle triangle way. The right angle triangle way of doing it is you say to yourself, stick to the blue again, we have a right angle triangle. In this right angle triangle, this is theta. We know this side, B sine alpha alpha plus beta, and that's a right angle. Now, we want to get this side here. That's the hypotenuse. And we know this side, which is the adjacent. So
Right.
the cos of theta is the adjacent, which is B sine alpha, over sine
Yeah.
alpha plus beta, over the hypotenuse, which is DE. So
Perfect.
therefore, DE is equal to B sine alpha over sine alpha plus beta over cos theta, and you can see we're back there.
Okay.
So it's a little bit more elegant, and I think that's why the maths teachers like it. But I've just found that most people will rather stick to the sine rule than
Yes,
go
and
with
I
the
think
right
that's
angle
better.
triangle, which is fine. You know, it's not a problem.
Yes.
Okay, let's finish the question up. Now it says calculate DE if B is, alpha is, beta is, theta is. Now I'm not going to take this right the way through because this is just straightforward calculator work.
All right.
Even if you couldn't do this first part, you certainly could do the second part.
Yes, ma'am.
So all you would go is you would go DE is equal to, and you'd replace your B with 2000, the sine of alpha, which is 43 degrees, and at the bottom here we've got the sine of
Sine of
43
79.
degrees plus 36 degrees, the cos of 27 degrees. I think we've got time to quickly whip it in the calculator and get an answer.
It's 1550.
Okay, now it seems like I don't have time, so I'm going to have to stop there, but you could input it straight into your calculator.
Yes, ma'am.
So it's a lovely little question, and as I said, this part is completely independent of that. So even if this was disastrous, you would assume this true and carry on going.
Yes,
So you
ma'am.
just write there, assuming 12.1 true, and do the question. Because obviously they're not going to ask you to prove something that isn't right. I think good luck with tomorrow, and if you need to phone in again, please do. Thanks for joining us.
Thank you so much, ma'am. You've been so much of a help. I really appreciate it.
It's a pleasure. And don't forget to draw that triangle almost immediately as you go.
No, I'm
there,
gonna
so you
memorize
won't
it
forget
tonight.
about it.
Thank you,
Okay.
ma'am.
It's a
Thank you,
pleasure.
bye.
Good luck for tomorrow. Right, everybody, we're going to go to ad break. Remember 0861 058 262 is our number, or www.facebook.com/learn extra. We will see you shortly after the break. Thank you.